Hello friends, today we will discuss the Euclid's lemma and its application to find the highest common factor of given two numbers. So let me state the Euclid's lemma. For given positive integers a and b, there exist positive integers q and r. These integers are unique one such that this statement will verify. So when a is divided by q, we'll get quotient q and remainder r. And remainder r is such that either r is 0 or 0 or r is greater than 0 and less than b. So in this context, this q is called quotient. This b is divisor and this r is remainder and a is dividend. So likewise, when 17 is, when you apply to algorithm for a equal to 17 and b equal to 6, so when 17 is divided by 6 occurs twice in 17 and leaves remainder 5. So 5 is remainder, 6 is the divisor and 2 is the quotient. So this is the Euclid's lemma. And how this Euclid's lemma is applicable to find the highest common factor of two numbers, I will explain in next example. We need to find the highest common factor of two numbers, 4052 and 12576. The highest common factor of smaller number can be found. What is the definition of highest common factor? If highest common factor of two numbers a and b is d, it should be the common factor of that two numbers, and there should not be the larger common factor among all the common factors of that number a and b. So it should be common factor, and among the common factor, that factor should be the highest one. It is also called as greatest common divisor. That is, it should be the common divisor. That if d is the highest common factor of these two numbers a and b, then d divides a, d divides b, and d is the largest one. So let me explain the Euclid's algorithm to find highest common factor of these two numbers by example. So I will write first step. You should assume the number a which is larger than b. So a is larger than b. So I give names to like this: a equal to 12,576 and b equal to 4,052. Now here, if a is greater than b, then applied Euclid's lemma that I have stated earlier. Apply Euclid's lemma to these numbers. So when 12,576 is divided by 4052, 4052 occurs thrice in 12,576 and leaves the remainder 420. This is the first remainder which is greater than 0. That means not equal to 0. If remainder is not equal to 0, we have to move further step. The divisor of this step is 502, earlier step, and it becomes dividend, and the remainder of earlier step becomes the divisor. So 420 occurs 9 times in 4052 and leaves remainder 272. So this is second remainder I can call 272, which is greater than 0. That means it is not equal to 0. Next step, if remainder is not equal to 0, we have to continue all the steps. Next steps. Now 420 will become dividend, 272 earlier remainder will become divisor, and it will occur once in that and leaves remainder as 148. So third step, remainder is 148, which is not equal to 0. So I have to move for next steps. Now 272 become dividend and 148 is divisor, and 148 occurs once here and leaves remainder 124. So fourth step, remainder is 124, which is not equal to 0. We have to continue till we get remainder 0. So 148 is divided by 124. 124 occurs once in that and leaves remainder 24, you can see. And remainder is, fifth remainder is not equal to 0. So continue the steps till you get remainder 0, and I will tell you who is the highest common factor of that. So 124 is divided by 24. 24 occurs 5 times in 124 and leaves remainder 4. So 4 is not equal to 0. This is sixth remainder. 6 step. So now I think the next step will be the last steps. In this step, we will get remainder as 0. 24 divided by 4, it occurs 6 times and lose remainder 0. So remainder is 0 in this step. This was our 6. And here, the highest common factor of that two numbers A and B is 4. The step at which you get remainder 0, the divisor of that or other remainder. So this will be the highest common factor of given two numbers. So why this is so? You can easily check that the 4 is highest common factor of 24 and 4 is, which is nothing but highest common factor of the 24 is earlier remainder and 124, which is nothing but highest common factor of 124 is earlier remainder and it should be 148. You can see it. The highest common factor of 148 is earlier remainder when it was divided to 272, which is nothing but highest common factor of 272 and 420, which is nothing but, so I'm saying that the divisor and the quotient have same highest common factor in each steps. So highest common factor of 420 is earlier remainder when it was divided to 4052. And at last, the highest common factor of the earlier divisor and your number A, 12,576. So in this way, the highest common factor of these two numbers is 4. So whatever algorithm I have applied here, that algorithm is known as the Euclid's algorithm to find the highest common factor. So what are the steps? Steps involved here. You should have A greater than B, and where A is divided by B will get remainder quotient Q and remainder R. If remainder is 0, then the B is highest common factor. This B is highest common factor. But if remainder is greater than 0 and less than divisor, then we have to apply step second. For what? B is divided by remainder and you get another quotient and another remainder. If this remainder is 0, then R is the greatest common divisor or highest common factor of these two numbers. If R dash is not equal to 0, we have to continue till you get the you get 0 as last. Like this example, you can continue. So in this way, the highest common factor can be computed. Thank you very much.